We are ready to start Unit 1-4, and we're going to evaluate square roots and cube roots. You know, no matter how I say that word, if I say it roots, that doesn't sound right. And if I say it roots, that doesn't sound right either. So, square roots and cube roots is probably what I'll go with. We've already done square roots, have we not? We just did a whole unit on that. We just took a quiz on it. So it should feel like familiar territory. We're going to learn about cube roots today as well. And that shouldn't add too much difficulty to what we're doing. All right, so our essential question, our objective today, we're going to evaluate cube roots and square roots. And by the end of it, I can find square roots and cube roots of rational numbers. Okay, here we go. Let's jump right in. Matt and his dad are building a tree house. They buy enough flooring material to cover an area of 36 square feet. What are all the possible dimensions of the floor? This is an interesting question. I like this question. I'm going to get this guy over here. Okay. And I think maybe I can even zoom in a little bit, get a little more writing area here, maybe. Ooh, wow, there we go. Maybe that'll work. Okay. Now I can write in this blank space over here a little better. So they are building a tree house. They've got enough material to cover an area of 36 square feet. So how do you find like the area of something like a floor, because that's what we're talking about, right? A floor of a treehouse. So Emery,
you do length times width.
Length times width gives you the area of a floor. So what are a couple of numbers that we could have that would make that 36 square feet? Really? Don't know two numbers that multiply to 36? So, okay, there we go. So we could have, see when I zoom in real big like that, it makes it kind of fuzzy looking, but that's all right. It could be 6 by 6, and that could be the area of the floor. Okay, there's one. What else could it be?
Times 9.
It could be that we have a square footage of 36 by doing 4 by 9 as our measurement. Okay, that's good. What else could it be?
9 times 4.
Well, that would be the same measurement. It would just be turned. So it was, yeah, but we.
2 times 23.
2
Or, sorry.
times.
Yeah, that's not right.
2 times.
16.
Not 16.
18.
18. Okay, so if we have 2, I don't know if that's to scale or not, but it's okay. 2 times 18, 2 by 18. What else could it be?
36 times 1.
It could be,
No.
1 by 36. That'd be a weird looking treehouse. Okay, what else could it be? There's one other.
Of 5.
Jump to 5.
I didn't draw this 2 by 18
12
right.
times 3.
7.
3 times 12. Okay, so that kind of, I think that gets it. 1 by 36, 2 by 18, 3 by 12, 4 by 9, and 6 by 6. Okay, so there's different ways that we can come to 36 being the square footage of the treehouse. Which ones make the most sense? Emery.
Probably, pretty much every single one except for the 36 by 1.
30, okay. 30, definitely not 36 by 1. That would be a really weird, I mean, that's longer than this room is and only 1 foot wide, which means I would not be able to stand in it because I don't know if you noticed, but I'm kind of a big dude. So that wouldn't make sense. Mason?
I think 312 6, and 9, 4 would be the only viable option.
312 would still be pretty narrow. I mean, 3 feet wide and 12 feet long. That'd be a weird looking tree to be able to get that in.
I feel like
Definitely
two would
6 by 6 and 4 by 9 I think are definitely reasonable. 3 by 12 is getting a little
No,
weird.
I don't think
2 by 18 is not gonna work.
Definitely
Okay.
like two.
Yeah, it's like this wide and not very, yeah, so that's tough. All right, so interesting discussion there to get us started, and all that. So just thinking about how those numbers relate to one another is good discussion. And all we had down there for that discussion was which one makes the most sense. All right, moving on. And I think for some reason this video is not working. I tried reloading the page, I've tried everything and it won't click play, so I don't even know what's on the video, so we're gonna skip the video for today. So probably something to do with the birdhouse, it looks like, is what you've got on your page, and I can't do that problem. All right. So we'll just jump straight into here. All right. So a cube-shaped art sculpture has a volume of 64 cubic feet. What is the length of each edge of the cube? So now we're talking about the difference between square feet that we just talked about with the floor of the treehouse, right? Square feet is how many dimensions? How many measurements were we talking about? We're talking about 2, right? Length and width. Now we're talking about a piece of art that it says is a cubic shape. So how many dimensions are we talking about there?
3.
3 dimensions, okay? So instead of doing just length times width, we're gonna do length times width times height or times depth, or however you wanna say that, right? So it's gonna be 3 dimensions instead of 2. And so that's why we call that cubing a number, okay? So we have square numbers, which we've been working with already in the last unit. And now we're gonna talk about cubed numbers. So the volume is 64 cubic feet, and we have this radical symbol, which we've talked about before. We've talked about radicals, right? I gotta get rid of this. Radicals are these symbols right here, right? That's a radical. So that's a radical, this is a radical. And we back up, get rid of that off the screen. When we just have that symbol, like we've done this one before, we've done 36 and we've taken the square root, right? So if we just have that radical symbol, then it's a square root that we're taking. But what's different about this one right here?
It's got a 3.
It's got a 3 in the notch. I don't know what
Yeah.
I don't know if that's the technical term or not, but I just always say what number's in the notch. 3 is in the notch. And so that tells us we're taking a cube root, okay? And so this is what we're doing, cube roots. So cube root of 64, well, what number cubed gives you 64? 4 times 4 times 4. Okay, 4 times 4 is 16, and then 16 times 4 again would be 64. So 4 cubed, this little exponent right there tells us that we're cubing the number 4. That's the same thing as saying 4 times 4 times 4. And since we have a 3 in the notch here, taking the cube root, then those two basically cancel each other out, right? You know, that means when we say that in math, they are inverse operations. They undo one another. And so the cube root of 64 is 4. And so then the length of each edge of that art sculpture is 4 feet. Okay? So we've been doing squares, and we make that list like on your quiz yesterday. We made that list of perfect squares, right? So we did we did 1 squared is 1, and 2 squared is 2. 2 squared is 4, and 3 squared is what? 9, and we did that, so on, right? We made this list. Now we're going to talk about a list of cube numbers, right? Cubed numbers. Are there going to be more? How's that going to relate to our list of square numbers?
Will we just
I don't know.
multiply it by
It's just gonna be
that same number?
Okay.
2 times 2, you just add
3.
3.
So 1 cubed is gonna be what? 1. 1 times 1 times 1 is 1. What is 2 cubed? 2 times 2 times 2 would be 8, right? And then 3 cubed. 3 times 3 is 9. 9 times 3 is 27. So these numbers get big really, really fast, right? 4 cubed, we already know from this problem, is 64. And then we're past 100. 5 cubed is 125. And so we get big really, really quick. Okay, so cubing numbers, there's a lot fewer, well, no. There's a lot more numbers in between the perfect cubes than there are in between the perfect squares. All right. Let's keep going here. So what's that look like? This is the type of thing they're gonna have you do. You know you're gonna have to fill in some blanks on the assignment, right? Because they always have you kind of do the steps this way as they show you in the book. So this one is the one we just did, A, where 64 is 4 times 4 times 4, and that is the same thing as 4 cubed, and the cube root of 4 cubed is 4. So then they're showing you this, like part B is 100, the square root of 100. And so this goes back to what we've already been doing, finding perfect squares. So 100 is just 10 times 10, which is 10 squared. So the square root of 10 squared is 10. Okay, any like super scary or ultra difficult ideas on this page?
Yeah.
I can't write on this page with their pen, so I'm not gonna add to it. Just knowing the difference between a cube root and a square root is what we're really focused on here. So here, I can write on this page, and cube root of 27. So cube root of 27, and the way they're working this out, they want you to, when you fill in the blanks, they want that 3 times 3 times 3, and then it equals, why is this not writing? Cube root of 3 cubed, which is the same thing as 3. That's a lot of 3's.
3.
Okay. And then for part B, that's just the square root of 25. And 25 is 5 times 5. So that would be the square root of 5 squared, which is 5. That's a funny looking 5 there in the middle. Okay, so what's the square, part C, what's the square root of 81? 9. It's 9 times 9, which is 9 squared. So the square root of 9 squared is 9. And the square root of 1, or the cube root of 1 cubed, or the cube root of 1, rather. Cube root of 1 is 1. Do you suppose we can do any other roots? If there are cube roots and square roots, do you think there are other roots that we could do? So could we put other numbers in the notch? Like, could I take, say, the 6th root of 64?
No.
You don't think so?
Yes, because it's a perfect
6
square.
divided by.
Not division.
No.
It is not
It's
division.
It's something multiplied to make it.
Something multiplied by itself 6 times to get 64.
2.
2 times 2 is 4,
4.
times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 32 times 2, 64.
That
So
was
2,
a whim. That was a guess.
okay, so 2, that would be like the 6th root of 2 to the 6th power. 2 to
Yeah.
the 6th power would be 2 times 2, 6 times,
I
right?
don't know my power.
And so these two numbers here, the radical and the exponent, cancel each other out. And the answer would be 2. The sixth root of 64 is 2. So we can do any root of a number. We're focusing on square roots and cube roots, so just the 2 and the 3 is all we want to do.
What would the sixth root be called?
The sixth root. They don't have, yeah, once you get past cube, it's just, you have the square root, the cube root, and then it's like 4th root, 5th root, 6th root. So you just use the number that's there. Okay. All right. So, we've got some word problems. And they do this one for you. Sean cuts one sheet of colorful poster paper to cover the bulletin board exactly. What are the dimensions of the poster paper that will cover the board exactly? So, what's the square root of 144? Well,
12.
12. Yeah, 12 times 12 is 144. So, the square root would be 12.
Cool. Sick.
All right. Emily wants to buy a tablecloth to cover a square card table. She knows the tabletop has an area of 9 square feet. So what's the minimum dimensions of the tablecloth that Emily needs?
3.
9 is 3 times 3, which is 3 squared.
Equals 3.
So the square root of 9 is 3. So the tablecloth should be 3 feet by 3 feet.
Dude, this is awesome. I love math now.
Good. You love math again? That's good.
I used to hate it.
Okay, well, we'll get there again.
But
Don't worry.
before I
All right.
did it, I used to love
Now, so before we start working through some of the homework problems, which I'm going to do some of them with you, how do you know in a word problem if we need to take a square root or a cube root?
Take 3.
It tells you.
Cube.
Well,
it says
what
cube.
what words can they use that will tell you? If it says cubed, I mean, if it's talking about something being a cube shape or a cubed, then that tells you you're going to take a cube root, right?
You might have to open the door.
That's the only way I can really think of.
But how many dimensions were square, like when we square something, how many dimensions are we talking?
3.
3.
No, 2.
2. So when we square something, we're talking about a 2-dimensional object, like the square footage of a floor, or something squared, some area that's just 2 dimensions. But when we're talking about 3 dimensions, we're talking about volume. We're talking about that type of thing. So we need 3 numbers for that. All right. Okay. So, here we go. Let's start working through some of the homework problems. What can we do?
What page is this?
How many choices do you have of what page it is?
2.
Like find it.
Found it.
Awesome. Okay. Number 7, relate the volume of the cube to the length of each edge. So if you have a cube with a volume of 8 centimeters, how long is each side of the cube?
2.
2. You can see it. It's 2 by 2 by 2. So it's 2, 2, and 2. So the cube root of 8 is 2. Right?
That was hard.
I said it's making more sense.
Good. The pictures help, I think, on some of these. So relate the area of the square to
16.
the length of each side. So the area is 16 centimeters, but what's the length of each side?
4.
4 centimeters by 4 centimeters. Therefore, the
It's
square
4.
root of 16
It's 4.
is 4.
Are we allowed to use a calculator on this?
Calculators are okay, but I don't think we'll need any because I'm here. I got you.
The goat.
We're doing the whole homework together.
Well, we're just gonna see how far we can get. Would you classify the number 169 as a perfect square, a perfect cube, both, or neither?
No, it's
Neither.
odd.
Okay. So what does that mean? It's odd.
Doesn't mean anything.
It's an odd number. It's
Okay.
neither.
So we have done our list of perfect squares up to 100, right? By going up to 10 times 10. We did that quite a bit in the last unit. So what if we kept that going and we did 11 squared? What is that?
132, or no, yes.
121?
121, 132. Wait, what was the 132 one?
It's not one. 12 squared is,
Oh, I was thinking 1444.
and 13 squared,
I don't know. That's a good question. 3 times 3 is 9, instead of 9, and maybe 3 times 1 is 39, and then, they do
I don't have
so much
time for this, 169.
Hey,
Okay.
I was close.
So 13 squared is 169. Okay. And then we need to think about cubed numbers. Okay, I'm gonna get back up where I can change my pen color.
Green.
Okay, so let's think about cubed numbers. So we already know that 4 cubed was 64. What is 5 cubed?
125.
5 cubed is 125. And what is 6 cubed?
So I did we 260?
216.
That's what I
Okay, so the cube numbers get big really, really fast, right? So we went from 125 all the way up to 216. So there's a lot of numbers skipped in there that are not perfect cubes. So 169 would be in between 125 and 216, right?
Yeah.
That means it's not a perfect cube. So what type of number is it if it's not a perfect cube? It's not, well, it is a perfect square. So as a perfect.
It's a square number.
Say it.
It's irrational.
It's irrational. The cube root of 169 would be irrational. Okay? Now the square root of 169 is
Neither.
rational. The square root is rational because the square root is 13. The cube root is in between 5 and 6. It's irrational. So we got to relate those two ideas, right? So this one is a perfect square because the square root of 169 is 13. Okay? So it's a perfect square, but it's not a perfect cube. Whew. All right. Volume of 512 cubic inches is what length? So 512 cube root. All right, so if we know that 6 cubed is 216, is it going to be less than 6 or more than 6?
More.
More than 6.
512.
So what do you think we should try?
7.
12.
7 cubed?
Yeah. Or 8. It might be 8.
I don't even have a calculator up here.
343.
343, thank you.
343. Okay, so.
And then 8 cubed. 8 times 8 times 8.
It's 9.
512.
It's 512.
I knew it.
Cube root of 512 is 8. So the length of each side of the cube is 8 inches. And we want to make sure we label stuff when we can. Okay? Square technology chip, number 11. Square technology chip has an area of 25 square centimeters. So if it's area, we talking cubed or squared?
Squared.
Yes. So 25 square centimeters, we're looking for the square root of 25, which is 5. And it's 5 centimeters. All right, so number 12. Would you classify the number 200 as a perfect square, perfect cube, both or neither?
Perfect.
Neither.
Well, is it a perfect cube?
No.
Nope,
well,
not a
it looks
perfect
like
cube.
Perfect square.
Is it a perfect square?
No.
No, it's
Maybe.
neither.
14.
14 cubed, or 14 squared, I'll tell you, is 196.
Whoa.
So
It's
it's not.
So it can't be. So,
That's neither.
all right, so this one is neither, and I would, we can define that as saying it's, 14 squared is 196, and 15 squared is 225. And then we could say 5 cubed is 125, and 6 cubed is 216. Okay, so it's in between those two sets of squares and cubes. All right,
Do your.
number 13, a company is making building blocks. What is the length of each side of the block? So how many dimensions are we talking?
One.
Dimension. 3 dimensions. So we don't want to take a square root, we want to take a cube root since it's 3 dimensions. Cube root of what?
1.
1, which is 1. So it is a 1 foot by 1 foot block.
Yeah.
By 1 foot.
Cool.
We heard it now.
You're awful grumpy for somebody whose teacher is doing his homework for him.
That's
I'm
crazy.
not grumpy, I'm just tired.
Miss Drew wants to build it.
Maybe I'm grumpy.
Can I read it?
Sure. Number 15, number 14, sorry.
Okay. Miss Drew wants to build a square sandbox with an area of 121 feet. The square feet. What is the total length of wood Mrs. Drew needs to make the sides of the sandbox?
Whoa.
So we have a square sandbox that is 121 square feet.
11.
So, okay, so how'd you get that?
Because 11 times 11 equals 121.
So what do we call that though? I mean,
The square root of
square
11.
root of,
11.
square root of 121 is 11. Is that the answer?
No. Well, yeah, because you wrote it all big and it's like lower in the right.
Yeah.
That was supposed to be the answer.
That's the answer.
So she needs 11 feet
Yeah.
of wood.
Yeah.
No.
No, she needs.
No, you need a simple sheet.
Oh, what's the total length of wood? So she needs 11, the perimeter of a box, right? 11 plus 11 plus 11 plus 11. That's 11 times 4 is
There you
44. So we got 44 wood.
Okay, so she needs 44 feet. 44 feet of wood to make a perimeter for the 121 square feet. That's a huge sandbox, by the way. My goodness, 11 feet by 11 feet.
Dude, I'm so smart.
You need a dump truck full of sand to fill that thing up.
Not really.
And then all the cats in the neighborhood that would, I don't even wanna think about it. All right, so,
That's the world's biggest litter box.
all right, it would be a giant litter box. All right, Diego says that if you cube the number 4, then take the cube root of the result, you end up with 8. Is Diego correct?
Diego's a liar.
Well, so if you take 4 cubed, get 64 is what he says. And then you take the cube root of the result, you get 8.
No, because the cube.
That is true.
You said cube root. That's a square root.
Ooh, you caught it. Good job. What do I need to do?
You need to put a 3.
Got to put a 3 in the notch now to
Ah.
cube root. But what is the cube root of 64?
4.
It's got to be 4. 4, cubing a number and cube root have to be inverse operations. You got to get the same numbers. So this is incorrect. Cube root of 64 would be 4. The square root of 64 is 8. Okay, got to make sure that you're working with the right operation. You got to know the difference between square root and cube root. Okay, number the next.
Okay.
16 here says, Talia, I don't know, is packing a moving box. She has a square framed poster with an area of 9 square feet. So the poster is a square with an area of 9 feet. So the square root of 9 is
3.
3. So it's a 3 foot by 3 foot poster. It's a big poster. Now the box has a volume of 30 cubic feet. So what do I do with that number?
You gotta,
Do I take a square root of 30?
yeah. No, you take the cube root 30.
Cube root of 30. Is that going to be a perfect cubic number?
No.
No. So you remember how we did this, right? You've got the cube numbers, which 3 cubed is 27, and 4 cubed
64.
is 64. I'm kind of writing over the top of all that, but that's okay. So 30 is in between those, right?
Yeah.
So
how
the
do you-
cube root of 30 is between 3 and 4. Does that make sense? Cube root of 30 fits in here somewhere. So it's in between 3 and 4. So is the box going to be big enough to hold the poster?
Yes.
Yes, because it's bigger than 3,
That's
right?
big.
And this is 3, the poster was 3, and the box is a little bit bigger than 3. So the answer is yes. The box is larger than the
C's the next one.
poster.
I think it's C.
Cool.
All right,
Record shop.
there we go.
It's C.
All right, so
D.
I got to clear my page here. Huh?
No, I'm not. It's A, because 49 squared.
It's quickest to clear it by doing that.
7 times, no.
Can you start on 17?
17.
Yeah. It's
Which expression has the largest value? So what's the square root of 49?
7.
So that would be
2 is 14.
7
so it is
times
C.
2 is 14.
So it's C.
Okay, what is B? Would be 7 minus 4,
That's
which
3.
is 3. C would be
5 minus 4.
what?
No, 5 plus 4 is 9.
5 plus 4 is 9.
But 5 times 3 is 15.
And then 5 times 3 is 15.
So it's more.
Okay, 18.
I wanna
So
read this
D is the one we
We
wanted.
got 4 minutes.
Okay,
All right. Okay, we got plenty of time. A toy has various shaped objects that a child can push through matching holes. The area of the square hole is 8 square centimeters. The volume of a cube-shaped block is 64 centimeters. Which edge length can you find?
4.
That doesn't answer the question. Can you find the edge length of the square hole, or can you find the edge length of the block?
The block. You can find
Why?
Because
4 times 4 is 8. 4 times 4 times 4 is
4 times 4 is not 8.
No, 4 times 4 is 6.
He's got you there.
What?
All right.
4 times 4 is 12.
So,
It's 6.
guys, the volume,
Quiet.
the area. Can we do the square root of 8?
Yes. No. No. There's no perfect. Yes,
No.
there is. There is a perfect. No.
Yes.
Yes or no,
Hold on.
Mason?
Hold on. You guys are, is 8 on our list of perfect square numbers?
No. There's
No, so we can't do the square root of 8. We can't do that. We can approximate it, we can get it close, but we can't do it because it's an irrational number. Can we do the cube root of 64?
Yes, that's 4.
That's 4. So yes, we can do that. So I'm okay with like a mathematical thing to show me the explanation. I can find the cube root of 64. I know how to do that one. Okay? So will the block fit in the hole? So if the block is 4 centimeters. Now, the square root of 8, we can't do that, but we can approximate it, we can get it close.
Yeah,
What, it's between what two perfect squares?
do one.
Okay, so 8 is in between 4 and 9.
4 and 9.
So when I take the square root of 4, that's 2. When I take the square root of 9, that's 3.
It's
So the
close to
square root
3.
of 8 is in between 2 and 3. So will the block fit through the square hole?
No,
I heard a no and I heard a
I
yes.
said no.
Yeah, no, it won't.
The hole's bigger than the thing.
No, yes it will, cause
Yes,
it's
it will.
8 is 3 and 2 is, yeah, it will. We're all good. It'll fit through.
It's 4
The
centimeters big.
block
Oh.
is 4
Oh.
centimeters.
It will not.
The hole is in between 2 and 3 centimeters.
It
It'll
will
not
not.
fit.
So no,
Told you.
the block is bigger. Block is too big. All right, goodness, you guys you lost your reasoning ability there for a minute.
We